everybody. Can you hear me?
Yes.
Yeah, it's clear. Okay. Hello, Giordano. Thank you to invite me to give this small presentation. So maybe I should share my screen, I guess. Can I do that? Yeah.
Of course.
Okay. Okay. Okay, so I just prepare one slide. I will talk about 3 different topics. Interactive geometry, what is it? Because this is something very specific to education in geometry. Then I will talk about small talk place in this interactive geometry. Then I will talk a little about Dr. Geo on quiz small talk, because since about 1 year, I'm porting Dr. Geo to quiz small talk. So I will discuss a little about that, on why I'm doing that, on what I'm planning to do later, if I can. So this will be the 3 topics I will talk about. Is it clear when I'm speaking? Can you hear me clearly, or?
So your voice is a little bit distorted. So I'm not
sure
you can get something by moving a bit away from the microphone, maybe.
Yeah, it's also a little bit loud. So
it's too loud?
maybe it's just yeah, you sound louder than the
okay,
other
so
people.
And now is it better?
Yeah.
I turn down the microphone. And now? It's okay?
Yeah.
I can continue? Okay. So I will start with interactive geometry. So I will just make a demonstration about a few stuff on interactive geometry. If at any time you want me to stop, or you need some details, some explanation, should I repeat something? Should I show something specific on what I'm doing? Please stop me. Okay, you just speak, and I will stop so we can interact. So maybe it will be more interesting also for you. Okay. Okay. So I will start with Dr. Geo. So the stable version, which is running on Pharo. Okay. Nice. So I will make a first construction about an interactive geometry sketch. I will take a very simple example, building a triangle. So I will first construct 3 sides of the triangle. Just doing like that. Okay. So we have this triangle. So we have the sides and we have the points. The point that will be useful for later construction. At this point, we already have something that is interactive. So we can drag the point, and of course it will drag the side. And you can also reverse dragging. So if I drag the side, it will reverse drag the point, then the other side. Yeah, so this is reverse dragging, something like that. So when you have a triangle, when you learn geometry in middle school, you learn about some special line you can draw on the triangle. For example, the perpendicular bisector. Okay, you can do something like that. Then you learn there is a property about the perpendicular bisector. They all join on one specific point. And of course, you can still drag around the triangle, and you can see that the property is still true. You can observe also when the point is inside or outside. How is the triangle? When the point, this center is outside and inside. So this is something that is related to the right triangle on the angles of the triangle. So, but we will not look at that. Something we can do with Dr. Geo when we start to have a sketch with some object, we can apply some styling to the object, not just for the beauty of the things, but to make something more obvious or to connect the things together. So the idea to plot with dots line is that the line will still be there, but it will, visually it will take less place. So when we have this center, we can draw the circle going through the 3 points. This is something we can do with the circle. Okay, here, Dr. Geo suggests we can ask for the intersection. So we construct it. Then we can take whatever the point we want. It doesn't matter. So here he proposed me, if you look, he proposed me to select the point. So this is flashing. It also proposed me to take a segment. So this looks a bit strange to draw a circle. The fact is that you can draw a circle through different means with Dr. Geo. It can be with 2 points, or it can be with 1 point on the segment. So it will just take the length of the segment to draw the circle. You can also take a value, but here there is no value. So this is why I have these 3 options here. So okay, let's take this point. So we can still apply the same styling here. We can paint the circle in blue. So we know it is related to the dot blue line we have here. Or maybe we can make it a little thicker. Okay. So here again, if we drag the triangle, the property will still be true, and we still have this construction. Another kind of line you can draw on the triangle is the what's the name in English? I forgot. The angle bisector. So the angle bisector is the line that going through the middle of an angle. So you need to select 3 points. So you have this line that is cutting this angle in 2 parts of equal measure. Then here again. So we have again this same property, and we have these 3 angle bisectors that are joining on the same point. Okay, I can ask what I did. Okay, no, I don't want to do that. Anyway. So, okay, let's undo this. Okay. So again, if I drag around, I have this point that is still going through these 3 lines. We can style this in green and do the same. Green. And the other one. Because at some point, when you have a lot of construction, you get lost. So that's coloring the line is very useful. So this is something that a student may do with Dr. Geo, but most of the time they come with some already done sketch, or they have a plane to follow. Then they have to deduce some properties. So here we have not finished, because from this point we can draw a circle which is inside. So this circle will be tangent to the 3 sides of the triangle. To do that, you need to draw a perpendicular. So a line perpendicular to this segment going through this point. Okay. This is not good. I would move a bit. Okay. So I can ask for this point. Okay. Then this line is not useful anymore, so I can hide it. I come here and I say, okay, hide it. I don't want to see it anymore. Then we can draw the circle. Circle, this point. Okay, so okay of this point. And I will paint it in green. Okay. So we have this three line that help us to build this inner circle. I think in English, inner circle. If it's too confusing, we can hide some stuff we don't need. We can hide these things. This one. This one.
Can I ask you something?
Yeah.
I saw that to draw this last green circle now, you had to draw explicitly a second point. Couldn't you do a constraint? That is, you say, you make a circle with center, like now you have this point, and then you say, the green circle is tangent to the, I don't know how to say, the upper line, let's say, the upper line.
Yeah. So this is not something that you can do from scratch in Dr. Geo. What you can do, you can teach Dr. Geo how to do that.
Ah, okay.
This is a macro construction. Okay, we can do that. So what we can do, it's very easy. So we will build a macro construction, because now we teach Dr. Geo how to do this green circle. So what we do to make a macro construction, we select, let's say we just select 3 points. 3 points. Okay. Then we say that, okay, I want this circle. So next. Okay. I'm not sure about the name in English, so I will call it inner circle. Description. Oops. Select 3 points. And apply. Okay, now if I go to the macro menu, I have this is a new tools actually. So I can come here and I can execute, for example, with this point. Oh, I need to select again. Yes, I have to select again. So this is the closest things you can do related to what you asked me. In this example, the output of the macro construction is only the circle. I could also ask to draw the side of the triangle. I did not. Yeah.
Excuse me, Hilaire, maybe I wanted to ask you something that is easier. I want to know if the circle has the concept of tangency. That is, if you draw a random circle, red, in that plane, and then you state the red circle must be tangent to the blue circle. Is it possible?
This is something that you have to teach to the... you want to ask a question, or you want to make a construction? This is not...
No, it doesn't matter. Okay, I can't explain probably. I can tell you by mail another moment. Go on, sorry, excuse me.
Okay.
I would suggest, Nicola, we get back to this one at the end, because from what Hilaire is saying, I think that there is a way, but he hasn't got to that yet to explain that.
Okay.
So let's leave it at that for now.
Okay. Okay, so this is one. Okay, that's one thing you can do with Dr. Geo, make constructions. You can also kind of discover some kind of properties. So there is a very famous sketch, which is the Varignon quadrangle. I'm not sure if it's, at least in France, we know about this one. So you just draw any kind of quadrangle. Oh no, what I did. Point. Okay. I'm not sure what I'm doing there. What I have done. Oh no. Okay, so I have too much. Okay, so I have this one. Then I will just ask for the middle. Oof. Then I will draw the polygon, the quadrangle here. So there is some interesting property to just discover that it's look like that we have a parallelogram. And so, of course, we can wonder, is it just because of this special situation, or is it something that is always true? So what we can do with interactive geometry, we can change the parameters, so the point here, and to see if this thing is still true. So it looks like that there is a property that is still true. So that can be helpful to introduce some things. Then after we can search how to prove that, okay, this is a parallelogram. So, okay, that's one way to use also interactive geometry in school to discover some properties or to introduce some properties to the students. Okay, so this is very classic interactive geometry. You can find there is many software. I guess there is maybe hundreds of software doing that kind of stuff. Some software are very famous. So, okay, this is just classic. So this is not very related to Smalltalk. It's only, okay, this is only written in Smalltalk, but there is not much about Smalltalk programming. So I will introduce the second part, which is about Smalltalk and interactive geometry. I try to mix these two things. I try to push the Smalltalk on the user side too, not only to develop the software, but also that the user, maybe not every kind of user, but some user, they can use Smalltalk even when they want to design some sketch or some special drawing. They can do that. So I will first show you a few examples of interactive geometry sketch mixing Smalltalk code at the same time on the user side. So the first example, okay, I will open Sketch. So some example. So this is the Newton telescope. This is a model of the Newton telescope. So what is it? So we have in blue, we have the mirror. So this is a parabolic mirror, a flat mirror, and this is the ocular. And in orange, this is the light beam. So this is a model just to show how the Newton telescope is makes the light to converge on the ocular. Okay, so here we can see that this is a small curve. This is not a line. So okay, we have mirroring. So we have a few properties of physics that are applied to make this sketch. Here we have a point, which is the focus of the parabol of the parabolic mirror. And what is interesting is that we can move this point to change the shape of the mirror in real time. So to see how, okay, I'm exaggerating to see how it's going on. So here we are concentrating maybe too much. I don't know. Can we move? No, that's not good anyway. Okay. So this example is using one feature of user programming, which is a script. So how does it work? The script, there are objects you will plug on the sketch, and they will do some kind of computation. Then you will be able to use this computation to do some other things. So they behave like a point or a line, and they can be used by other objects. So let's see the script, because the script, they are here, they are hidden, so I can reveal them. Oops. So we can look a little about. So we have this object. So you see when I drag these things, so this is a script. That what you tell me, this is a script that the name is parabola function with one argument. And the argument is the focus. If you look, this is a closure actually. So this script is just returning a closure. So what it does, it just take this point and it use it as a parameter in the closure to define the parabolic curve. That's it. On this one, this other script, it return a point. On this point, actually, it depends on two other objects on the sketch. It depends on the light beam, and it depends on the closure, the other script. So this is a script depending on another script. So these things, if you want to look how is the code, okay, you can come here. So this is a browser. Actually, this is a browser on this script. So a script is a class. Then when you plug it in a sketch, this is an instance of the class. That's it. So here we have only one method for the script. That's the compute method. This is the basic method that just does what it does there. Yeah, the same things. On argument one is the first argument of the script. This is this point. If you look at the script data, in fact, this is the class side of the Smalltalk class. So we have the script name, parabola function. We have the description that we can find here. No, they are not here. I don't know why. Yeah, they are there. Sorry. Oh no, I don't know why they are not here. Okay, anyway. And you have the arguments, and you see the arguments is a point. Okay. So later I will show an example how to create a script. Okay. So if we look to, okay, just to show you how it is behind the scene, I will open a system browser just to show you that there is no, it's just so normal things for us. This is the script, you see. So that's the same script. So this is easier for the user because there is not all the stuff around. You see, that's easier to understand. But if we took with the normal browser, we can see the same things. Then the class side, this is the script data. Okay. So every time you want to use this script, you will create a new instance of this class. That's it. So you can use a script to make computation on object, but you can also use script to modify some other object on the sketch. I will show you another example I wrote to be used in primary school. Okay. Rectangle, no. Okay, this one. Yeah. So this is a very simple simple sketch. The user can do nothing, can only drag the point here. So I'm sorry, this is French, but okay, this is a script. You print the result, and it just say what's wrong about this quadrant. We want it to be a parallelogram. So he say, oh, the side, they are not of the same length, and they are not parallel. Okay, maybe I can change a bit, do something like that. Oh, okay. So here you can recognize, okay, this is a parallelogram. In fact, this is a rectangle. Okay, so if I move again, oh, this is wrong. Okay, so I can see this is a parallelogram. So the script is just the script just does the computation to recognize if the shape is a parallelogram. Then, if this is the case, it prints something appropriate. Then it paints in blue the quadrangle. So that's all. So that the other kind of things you can do with the script. So I will show you a small example how you write a script. So let's say we want to make a script to compute the distance between one point on one line. So this is something you can do with Dr. Geo actually, but we can make this. But okay, let's say we take a point, then we take a line, and we want a script that will compute the distance between this point and this line. So this is the shortest distance. So this is a perpendicular. You need to go through perpendicularly. So when the script will require one line on one point, of course. So let's create the script. Okay. Create the script. So we say that the name is line distance line point description. Select a point, a line on a point, and will return the distance between these two objects. Okay. So then the argument will be the line and the point. So we had one argument. The type would be a line. And the second argument will be a point. Where's the point? Here. Okay, so now we can build the script. So the script is built. Behind the scene, a new class is built actually. So we can check the script data. We have the script name there, descriptions, and new argument types. Okay, method. So here we need to do something actually. So, okay, you need to know a little about the object. So the first argument is the line, if we remember correctly. So we will just do a dot product. So we take one point on the line. Each line, they have an origin. So we can ask the origin, which is a point. Okay, we can just try that to see. So the script is not finished, that's just trying. So if we want to use the script, I will ask for the distance, line point. So I select the line, the point, I click there. Okay, this is a point on the line. I can probably show with the axe. So I'm not sure where is this point. Yeah, something around there. Oh, this is this point actually. Yeah, this is the first point. Yeah, this one. So of course this is not what we want. So we need to edit the script again. Okay. I don't like that. So, okay, that's good. So we need to compute. So the vector with this point. So this is the second argument, and we ask for the coordinate. Then we will make the dot product with we need the normal vector. So we can ask this to the line too, of course. So normal. I think this is normal. Yeah. Yeah. I don't need this. Okay, so this is mostly done. Mostly, we can just check if something is look correct. Yeah, that's look correct. 3. Yeah. Oops. Oh, we have something wrong. Of course, we can have a negative dot product. So we need here to ask for the absolute value. And then we fix the script. Okay. So you can see when you write a script, you do it as you will do with Smalltalk, actually. Just figure out the things, fixing, and this way. So this is one way to do programming with the interactive geometry. So these things I never use with the students, actually, because it's a little too technical. So there is another way to do programming, Smalltalk programming. On this one, I can do it with the student. So I will show you another way to use Smalltalk with Dr. Geo. So the idea now is to forget to forget about the user interface. So this time we start with the workspace. So there is a specific I should say domain-specific language, something like that, that you can use to define the sketch through programming. So you will just write small code to do that actually. So I will ask Dr. Geo. No. Sketch new. So okay, I got something that is empty. I can ask also to print the axe, for example, with the axe. Okay. I can ask with the grid on. Okay. I can do something more interesting. I can make some point. So I have this point. Of course, the result is an interactive sketch. So what we can try to do is to make maybe like we did the first sketch I did previously. We can make a triangle, a complete triangle, to see how we do that. So we ask for the side of the triangle. So yeah. Okay, this is what we got. Yeah, how to close it. Yes, and we can do like this for the other side. 0, that's 5. Then okay, classic. Now, if you want to, maybe we need to name this side. That can be useful. Maybe not all. Okay. So what we can do, we can ask for the perpendicular bisector. So let's say that we want the perpendicular bisector to A. See? Bisector to B. Then we get these things. Okay? So this is still an interactive sketch. So this is something that I find that is easier for a student to use and to teach some basic programming. So what we can do now, we can ask for the intersections. Intersection. Okay. So why is it? Yeah. I need to use parentheses, of course. So you see that each time you create an object, you have a reference to it, then you can use it for later constructions. So we have the point here, and now we can draw the circle. So circle, center O, and this going through. Okay. So okay, we got the same construction we did previously. You see. So these things, okay, that's very. There's nothing special about programming, in fact, because it's just declarative instruction to do something. That's not very different from what you will do with the mouse on the menu I did previously. There's nothing special. So when it becomes interesting is when you start to use the construct of a language like the collection on the loop. repeat some sequence of construction. So what I did with for my students, I have some. This is sorry. This is French, but this is just to show you the kind of document I gave to them. So this is an activity paper. So okay, this is introducing the freeze. You see, and they have an example, and they can write it. So they have the result. The first thing is to type in. And after they have some other example, then they have to modify this one to get the same results. Then there is some element about the new thing they just learned with these things. So if you write, so what is interesting, in fact, is to have collection. So I would not type in the example. I think I have it there. Okay. So okay. So this one is more interesting. This example is more interesting because we create several segments, but we put them in a collection. Then to this collection, we will apply some stuff, some transformations. So I will just run the script to show you the result of these things. So the idea is that you have the basic shape that you put on the collection, then you use these translations to translate and to make the freeze very easily. So here in this case, using programming is very effective because if you should do that with the mouse, it will take too much time. Okay. Of course, the result is something that is interactive. Okay, you can see the link between the object. Okay. So you can even transform these things to make something a bit different. So this is a collect that is used, but you can also just make to the collection. You can apply some transformation. So let's say that this time we want to the symmetry of each shape, and we will use the center 0, 0, for example. So, okay, that's the result we get, of course. Maybe I should. Okay, so we have the symmetry through the 0 point. Okay. So I think I'm almost done with the presentation of the most important facet of Dr. Geo. But I will show a little about quiz, should say, and why I'm planning to use it. So quiz actually I need here. Okay. So why I decide to go to quiz? It's because when I look at quiz, I like the simplicity I can find in the system. For me, it's easier to understand. So this means that I don't have to spend too much time to understand the system, and I can focus on working on Dr. Geo. I also like the new design of the morph system. It's very, very, very good. Juan changed a lot of feature. The coordinate is easier to use. It's easier to design the morph. Of course, it's using a vectorial engine, which appears to be quite fast with the plugin. So also I want to explore the user interface. I want to think about new way of interacting with the software. So I did some work previously with circular toolbars and things like that. So actually, is quite working quite well. We can even now we can load the sketch of Dr. Geo. So for example, this one is a sketch with script. So okay, there is the printing is not that good, but this is an interactive sketch with a few script with a curve, a computed curve. Then you can you have the tangent line that is interactively computed, and you can move it along the curve. So this is working perfectly well. So far, the user interface is looking like that. So Juan, I saw your email about how it's looking like the user interface. So you see the interactor should be there in the corner, not in the middle. So now it's only with menu. This is very basic user interface, but I plan to do something more fancy. But it's working perfectly well. Parallel. Oh, I've been too fast. Okay. Oh, okay. I do like that. Okay, anyway. So it's quite nice. I can show you a few examples of other Smalltalk sketch. Yeah, I forgot to show one. Yeah, I forgot to show another one. Maybe, okay, let's see, open. I will show with the quiz. So maybe something will not work perfectly smooth. I hope it's okay for you. Picture. I'm lost. Trunk. Build. Okay, yeah. So maybe I will show you the Newton numeric method. Where is it? Newton-Raphson. I will change it because, yeah, I would say it like that. Yeah, it's going to be more interesting. So this example is to illustrate the Newton method to search for the root of a function. So this is an interactive diagram that's meant for students to explain them how it's working the algorithm. So okay, we can come here and see. So we can see that depending on the initial value you take for this numeric method, this will converge and find the zero more or less quickly. So if you go there, of course, you will not be very happy because the tangent line is going very far. You see, you get lost actually, but it doesn't work. So that shows how it is important to search for the good initial value actually. Okay. Okay, so this is one example. Another example of Smalltalk sketch. That's this one. This is to compute with probability, not probability, with statistic. An approximation of pi actually. Yeah, I tweet about this one, and I know some people were not very happy because it's very much faster than Pharo, because I think it's because of Cairo actually on Pharo, the way that Pharo communicate with Cairo. So this one is running just very fast. So there is only 2,000 value, maybe 200, maybe 2,000. It will be better. Of course, it will take more time. No, it's okay. So this is not very good way to search for the value of P, of course. So this sketch is done the same way as I show you previously. So this is the same way of mixing interactive geometry on code and doing the sketch from scratch with Smalltalk code. Actually. Just gonna show you some more. So what you can do also is to make, of course, if you are doing programming, you can make some recursive curve, of course. Yeah. So now the difference with a classic curve is that this curve is dynamic still, because if you look behind, there is a lot of constructions that were idle to make this complete interactive sketch. Okay, so if I decide to zoom in, okay, I can zoom in the curve, then I can change the initial value. So this is a dynamic sketch. And this one too. Same thing. Yeah. Oh, this is interactive. I think which one I want to show. Or maybe you will remember this one from senior high school, I think. This is when you search when you search with a sequence, you search for the convergence of a sequence. This is the I think in English it's co-web, and depending on the initial value, yeah, on the shape, we can have something that is converging more or less quickly. I zoom at the maximum already. Yeah, I think I'm done. Yeah. Yeah.
Okay.
Yeah.
Thanks, Hilaire. There's a couple of questions that Bruce has posted earlier. Bruce, would you like to repeat your questions?
Oh, sure. So one was when you're actually using the editor, is it possible to multiple select things? Because there were some instances where you would say get several lines and you wanted them all to be blue or red. Is there any way of just going through shift clicking all the lines?
You mean group selection?
Yes.
Yeah, that's something I implemented many years ago when I wrote the first version on Squeak. Then I did not keep it. I removed it. So it could be possible, but it's not present actually. Yeah, you have to do one by one.
Now, because a lot of the way you're using it is driving it through scripts rather than driving it through the editor. So multiple select is less powerful in that sense. But you're not going to use it very much because you're mostly doing it by driving it through the code.
Maybe I don't understand your question, I think.
Well, my question was, do you have group select? And the answer to the question is no.
Yeah.
Fine. But I can understand now, having seen your entire demonstration, why perhaps you don't have group select. Because a lot of the time, you're using code to build things and not using the editor to build them.
That's not the reason. I think the main reason is that because this is with Dr. Geo, you will not make a very huge sketch. You will use with student and they will draw maybe at maximum 10, 20 objects. So maybe they need to change the style of a few objects. So you don't have this requirement to make group selections and to change the style or apply a specific style. It's because I did not feel these needs when I use it with my students. Because the software, the user interface, there is very subtle way to interact with the software. I'm not sure you can't see that, but the way you can select the point, how you can drag them. I spend a lot of time to observing my students. Sometimes I use the software and I see, oh, they are doing that way. Maybe I can improve that things. So I can make some very subtle usability improvement, because the student they are not professional. I mean, they will not use. No, I mean, they are not professional on Dr. Geo. They are professional with using the smartphone, nothing like that. But this software, they will use it only on maths, and then maybe a few times on the school year. So they are very basic needs. And if you go with there is some advanced feature, they will never have the time to use it. Actually, maybe the teacher they could enjoy it, but for the students, what is important is that you have the simplicity of use, the less surprise. Also, that's very important. They should not be surprised when they interact with the software. What they get should be what they think they will get. So the student, the age is going from is 12, I think 12 to 15. Yeah. And the programming I'm doing with the 12-year-old kid. So I have two period lessons. So this is two period of 45 minutes. So for IT teaching, normally we don't do much programming, but I do anyway. So I reserve one period of 45 minutes to work on the programming activity. Then for the second period, we do something else, because this is it's quite demanding for the student, especially when they write the code. They need to be very careful on what they are writing. They need to know the keyboard, how to get the shortcut not the shortcut, the shortcut too, but how to get some special key. So I teach them before, of course. And they quite like doing that, actually. Not too long, but I think they quite like doing that. Yeah, that's a very interesting experience. Yeah.
I have a few questions if you want.
Yeah, go on.
Okay, the last drawing I saw of the cock curve and how much complex it was, the construction, made me think that maybe you don't have turtle geometry in there, right?
I don't have the what?
Intrinsic geometry, let's say the turtle.
The total?
Yeah.
No.
No, you should add it. That's very easy.
It's Euclidean geometry, actually.
Yeah, okay, so that was the thing. And so the second question is actually another version of what I asked you before. So the system, as far as I can say, manage only linear equation. Am I correct?
Yes, yes, you can say that. Yeah.
Okay, so now I understand. Okay,
Yeah.
this answers also my previous question. Anyway, it's very nice. I think it's can be a very good introduction to programming. It's very nice to see. It's very good.
Hilaire, I have a different sort of question. So you started Dr. Geo, in C++, then you ported over to Squeak, then Squeak to Pharo, then now you're going over to Quiz.
I see where
Can
you're
you say something about your experiences in doing all these evolutions?
What the last sentence I did not hear quite great. What the experience?
So you got your application going through different languages and different dialects of Smalltalk.
Yeah.
from Squeak to Pharo and now you're going to Quiz. What can you say about what have you learned about doing this
Okay.
multiple times?
Okay. So actually, there were two versions of C++. The first one, maybe you did not notice, was for on DOS a very long time ago. DOS, you know DOS?
Yeah,
DOS? Yeah. So MS-DOS, and then I port to Linux, and then after to Squeak. So yeah, that's when I switched to the main things. The astonishing things was when I moved to Smalltalk. Actually, it was very a shock to see how fun it can become to code Dr. Geo. It's really become very fun because with C++, okay, you know the stuff. You need to compile, and then you have a bug, and then you have to change the code, and like that. So all these things were suddenly they were gone. So it became much more pleasant to code with Dr. Geo. That's the first things. Then the second things also very important because I'm not a professional developer. I have a job, a daytime and family. So I can have quite long period of time where I don't touch Dr. Geo. So the problem with the C++ version, when I was doing that, for example, for 2 months, I don't touch the code. And then when I come back, my head was kind of exploding because I need to look at the code and to remember what I did, what was the stuff, and that was very complicated. And these things, when I moved to Smalltalk, it was much more easier to get back in the code to understand what was going on. So that was the two things that I remember. The first thing, it's easier to code with Smalltalk. Then the second thing, it's easier to get back in the code you don't touch for a long period of time, and that's very valuable actually. Yeah. I know, micro. We don't hear you.
Sorry, I said thank you. Okay, any further questions?
Yeah, Lost in English wanted to know if there's support for 3D, but he had to leave early, so I'm asking his question for him.
For 3D?
Yes.
No.
Okay.
No. What I would like to do, the next thing I would like to do is to think about, because Dr. Geo is for math teacher, okay? What I would like to think is what it will be to have that kind of different brick in Smalltalk, but for different kind of subject that teacher teach. Actually, I mean for English, for geography, for history, for physics, and to mix all these things in a Smalltalk system. So that would be something that the student they could use, of course. The teacher also, maybe the teacher, maybe they will not need to mix, but for the student, that would be something interesting. So this is something I want to think about, how you would do that. For example, imagine for geography, you have I know that the teacher on geography or history, they use some kind of special drawing they have maps, or they have time rules so you can have this kind of interactive stuff on where you can also mix some Smalltalk to improve not to improve, but to enhance what you can do. You see, because the programming stuff you can do with Dr. Geo, you can do much more than you can do only with the user interface. So I want to also to think about this kind of idea of mixing programming on software, on user software, to on other domain of teaching.
One question, Hilaire, with respect to that, what you said just made me think. Geometry is a formal system, right? There is not much factual data, but just a few definitions, and all the rest is a formal system. But history is mostly about facts, about data, more than a logical system. So you think you would also need to include some way in Smalltalk the historical facts that the teacher needs to deal with, right? So it looks like a big database or something like that.
Yeah, there is indeed there is some data aspect also. If you want to do something in to teach English or rule like that, you need also to include that kind of things. But you can have also, for example, you can have this kind. You can have a maps, and then you can create new way to interact with the maps. So this is the part where you will do it with the Smalltalk stuff. So you will have the data, but you will also have this Smalltalk dimension. That when you can boost the creativity, yeah, the idea is you can boost the creativity on what you can do with your application.
Yeah, that sounds like a very interesting project.
A different idea would be, you can show things, if you stay into history, going beyond stuff like battles or treaties or whatever. I could see a tool such as Dr. Geo to show, for example, how how the economy worked in the Roman Empire.
Mm-hmm.
How you could bring something from one place in the empire, and then it would trigger this other commerce going, and all the things would end up in Rome. Just to make an example, or
Yeah, with the model, the kind of model.
Yeah, or the age of exploration and how different explorers have been moving around in the same areas in the 1600s, in the 1800s, or whatever. And you can see.
Yeah, there are a lot of dynamic processes that can be made interactive.
Yeah.
But to do it right, you need to do it with teacher. I mean that they know because okay, me I can do it in maths because I know this topic, so I know what I need and where I can make the thing more creative. So if you want to do that on let's say geography, so you need to do that with a geographic teacher, or you need to discuss with them to see what they do, what they would like to do, what they will want to be able to do to show to their students or to share with their students. And then you can start to think about what kind of model you can try to think. And maybe you need to have several models. Like you say, for math and geometry, it's very complete things, so it's easier. So maybe for some topics you will need several more. Yeah. So it needs exploration. But the fact is that when I look to the society, if you look at the society, one thing that shocked me is that if you look in the society, the computer, they are used everywhere. And the people they are using the computer, they have the tools they need. I mean, they really have the tools they need. If you go to the supermarket, the cashier, they have a special machine. It's a computer dedicated for the task. But if you look at the students, they don't have the tools they need. So they're just using computer, and they put some software there, and then from time to time they are using it. But it's not really the tool they need, and they can use daily actually when they learn. So that's something that is really strange for me. Maybe it's because the education is not a market when you can make a lot of money. I don't know. Maybe this is because of that. Because it's very shocking. I mean, that's not shocking, but surprising actually. So they're in the school. They're just taking the computer stuff existing there, and then they take it. They have some special software like Dr. Geo, etc. but the students,
Question.
the student themselves, they are still big bag with books, paper books, with the textbook.
Can I ask a question?
Yeah.
Yeah. I mean, you bring up about education, which is, of course, extremely relevant. I was thinking, have you thought of combining Dr. Joe into a curriculum or a tutorial, which will become, the standard for geometry education?
You mean to see how it's matched with curriculum, or?
Yeah, I mean, create a curriculum, a comprehensive curriculum for geometry using Dr. Joe.
Okay. Oh, no, I don't do that. What I do is, when I need, what I do is more practical. Okay, when I want to do, I teach some topics, and I think I have the interest of the student, I will prepare some special activity, like the one I showed previously, about programming. So then I will do that, but I will not do all the curriculum, because anyway,
have that activity that you have, can I find it online and reproduce it?
No, they are on my, but I can share with you. I can share some of you. They're on my computer, but I don't share them.
I see.
Yeah,
so you don't want to make it, like Khan Academy or things like that.
Yeah, no, that's because I never, frankly, I never thought about that, because I just think that's the document I'm producing as a teacher. I mean, like all the kind of documents. So I never thought about sharing that, put it in a website or something like that. No.
Right.
Yeah.
Because I think the software can be used to explain geometry very, very well.
Mm-hmm. Yeah.
Which a lot of schools will need. And if you can make it available to them as part of a class curriculum, then the adaptation would be pretty high.
What is happening in the school? I mean, at least in the school I know, is that most of the time, the student, they don't have a computer they can use. So, for example, in my school, if I want to use a computer, I need to reserve a special classroom. Then I will be able to go to this place for 45 minutes. But at the other time, I will be in a classroom where there is only one computer for the teacher.
Sure.
Have you thought about the possibility of doing, as you do, a demonstration on the teacher computer at the school, and give students homework to do at their home computer? That perhaps could work.
Yeah, that's thing I do to show them to show them at the computer, but I never ask them to do at home. No. Why? I don't know. Maybe I don't feel sure about that. Maybe I don't. I ask them other stuff to do on the computer, actually. So, yeah.
The other possibility is making YouTube's videos of your activity.
Yeah.
You have some, right?
I have some, yeah. This is very rough, but I have some, yeah.
Right.
I don't enjoy that much doing that, so maybe that's why. I don't know.
Sure, I understand.
Yeah.
Yeah. Okay. Thank you. Congratulations on creating a product.
Thank you.
All right.
This is a question to everyone, but first and foremost, of course, to the presenter. Does anyone know of Smalltalk non-Euclidean geometry implementations?
No, I don't know.
I was kind of expecting that answer, but it's an area of interest, so I thought I'd ask. Guess I'll have to write it myself. Hello?
After I saw your question in the chat, I looked it up because I thought if anybody would have it, would be the MathMorph guys from Argentina, because they did lots of weird math directions. But I didn't find anything. I'd have to dig deeper. Maybe they did, but.
Okay, well, I've registered my interest. Thanks very much for looking.
Thank you.
I think that is starting from Hilaire program, it could not be too difficult to implement projective geometry, okay? But for other thing, no, because it's linear, so it's linear based, so other things can be more difficult. But projective is nearby.
Yes, I'd take your point. You could probably do that quite easily. But if you were trying to do Riemannian, for example, then it gets a bit more complicated.
Nothing differential, nothing.
I've done a lot of generation of object graphs for the hyperbolic projection system Walrus that's written in Java, and I would love to port that to Smalltalk, but I haven't done it yet. I've only been making data input for it.
Okay.
There's,
I got any more questions?
I have another sort of set of wacky ideas just to talk about something that's more far out. This is an ancient game called Physicus, which is you know, these interactive video games. But they have a huge amount of simulations of sound and springs and light and all kinds of physical characteristics with the maths and simulation, which would be a really cool thing. And I was thinking that a decent use of AI would be a personal tutor. Think of a Dynabook with a personal tutor in it that would learn about you and how you learn, and whatever you were interested in learning about would help you learn that. That would be a really good idea for AI. And you know, this type of thing is kind of the front end to that that aspect of things. Just a thought. You know, what I may as well think out there, right? So anyway. Thank you much, Hilaire. Wonderful.
Yeah.
Yeah.
Well, this is not a question at all, just a comment. I want to say thank you, Hilaire, for doing Dr. Geo. It's a wonderful project. I'm sure it's helping a lot of kids in school understand geometry better. And it's also a wonderful showcase for what Smalltalk can do. I love it. Thank you.
Thank you, Juan.
A silly question now. Is just a package that I can load into Quiz?
Yeah, there is a package. I will.
Okay. I will try as well.
It's deep on the web, but it's not public yet. But I can publish the address on the list.
Yes, thank you. Yeah, we'll try. If it's a package, I try to load it.
Yeah, it's very easy to load. Yeah, there is thanks to the easy dependency system of Quiz. It's very.
Because I must tell you, I tried to run Dr. Geo like 2 years ago in my first experience with Smalltalk.
Okay.
and I couldn't run it. Okay. So.
You're gonna run it. Okay. Yeah, there is some issue. It depends if you're on Mac maybe or Linux. Yeah. There is 32 bits on VM and 64-bit systems. Maybe that's some.
Yeah, probably there was a 32-bit story, because then maybe you had an assistant that time, a woman, and she told me something about 32-bit or something, but then I gave up. It didn't work. Well, but now it works, so I will try.
Now you can use it. Now it's working.
Okay, good.
Okay. Yeah. So yeah. Yeah, you're 11 years old. Yeah, you can try. Yeah, sure. You can also try some. I suggest with your kids, with your 11 years old kids, you can try programming. Actually, the documentation in English is not good, so you have to look at the. If you want to, okay, I will just show you very quickly some things. If some of you they want to use with the kids, because the documentation, I have good documentation in French, but not in English. I'm sorry. So if you need to know how to use programming, because I think that's the most interesting part. You come here, you open the, oh, maybe I should share my screen. Sorry, oops. Okay, I share my screen. Okay, so I show you how you can use, if you have a kid and you want to use it with your kids, what you can do. So when you start AutoGeo, of course, you open the workspace, you wrote the code here. Then you can search for the system browser, and the system browser will open on this class. So this is the class where you have all the methods to use to create the object. So this is all the place that you need to figure out. Okay. Yeah, you can check there. So Dr. Geo sketch, if you do Dr. Geo sketch new, okay, you can do. Then after you can see what you can do. That's all the place to look. Not yeah, curve, yeah, whatever. Yeah, the documentation is here. Or if you can read French, you can search on the Dr. Geo website. There is programming user guide, but it's in French. There is one in English, but it's outdated. It's obsolete. Yeah.
I actually also found all the directory had all your ST files, Smalltalk files, which make a good starting point.
Mm-hmm. I don't hear.
Sorry, I was just saying that thanks for pointing out where to start looking.
Yeah.
And I also found you have the directory that you showed where you're calculating pi. So all of those Smalltalk files make a good starting point. Good examples.